For years, there was one question that Western aviation analysts always answered with confidence. No way. China could build its own aircraft carriers. It could develop stealth fighter jets. It could send people into space. But a next-generation jet engine for commercial airliners? Never. That was the final territory the West still had firmly under control, a field where, after decades of technological buildup, hundreds of thousands of test hours, and countless expensive failures, companies like CFM, Pratt & Whitney, and Rolls-Royce had built a wall that nobody could climb easily. But in early 2025, a technical report landed on the desks of analysts in Europe and the United States. And according to people familiar with the situation, the reaction inside companies like Boeing and Airbus was anything but calm. Because this was not some symbolic test. It was the clearest signal yet that China, through an engine called the CJ1000A, may be much further ahead than the world once believed. So, where does the CJ1000A really stand in this race? And if it succeeds, what could it change in the balance of power across the global aviation industry? To understand why this engine matters so much, you have to look back at the dangerous gap China has been forced to live with for years. China built the C919, its first domestically developed narrow-body airliner and a direct rival to the Airbus, A320neo and Boeing 737 MAX. That alone was a major engineering achievement. But there was one detail Chinese officials were never comfortable talking about. Every C919 flying today depends on the LEAP 1C engine, a joint product of America's GE Aviation and France's Safran, a made-in-China airplane powered by a foreign heart. And the problem was never just national pride. The real issue is simple. Whoever controls the engine controls the entire program, and that has been proven in reality, not theory. In 2020, Washington considered blocking LEAP engine deliveries to China. Then, in 2025, the United States once again paused export approvals. The effect was almost immediate. No missiles, no sanctions package. Just one administrative decision. The C919 assembly line had to slow down. Deliveries that airlines were waiting for suddenly stopped moving. COMAC's plan to deliver more than 30 aircraft that year was cut to just 25. 4 airlines that had already placed deposits had to push back their schedules. Pilots trained to fly the C919 were left waiting because there were no new aircraft available for them. That pause only lasted a few weeks before approvals were restored in early July. But the real damage was not the number of delayed airplanes. It was the message the event sent. The C919 might look ready for the world, but it could still be switched off with one phone call from Washington. With China expected to need more than 9,500 new aircraft over the next 20 years, that is not the kind of risk any long-term strategist can accept. That is why the CJ1000A is no longer just a long-term research project. After 2025, it became a critical part of China's entire civil aviation strategy. But to really understand this program, one thing needs to be clear. The road to the CJ1000A did not begin because of outside pressure. It began more than a decade ago, when engineers at AECC, the Aero Engine Corporation of China, were given the task of building something the country had never produced before, a high-bypass turbofan engine in the same class as the engines powering the A320neo and the 737 MAX. In 2011, a model of the CJ1000A appeared at the Beijing Air Show. At that point, it was mostly a statement of ambition. Then, in 2017, the first full demonstration engine was assembled. It was not built to fly yet. It was built to answer one question. Could China's engine core reach the speed and temperature needed for commercial aviation? In 2018, the answer came. Inside a test facility in Shanghai, the CJ1000A reached full core speed for the first time. That was the moment the program moved from drawings and concepts into real hardware. But building an engine that can run and building an engine that is reliable enough for commercial service are two completely different things. The next stage, from 2019 to 2022, was the slowest and most brutal part of the process. Engineers pushed the engine through every extreme scenario they could think of. Temperatures as low as -40 degrees, heat above 50 degrees, sudden load changes, bird strikes, and mechanical vibration. Every test was not just about proving that the engine could survive. It was about finding every possible weakness that could destroy the entire program 5 years later. At the same time, COMAC prepared for a major step forward. The CJ1000A would be mounted on a Xi'an Y-20 heavy military transport aircraft, replacing one of its 4 standard engines. That gave engineers a way to collect real flight data without risking a passenger airliner. Basically, it turned the Y-20 into a flying test laboratory. By 2023, pictures started showing up on Chinese social media of a Y-20 flying with the CJ1000A, replacing one of its original engines. The program had entered the stage where most engine projects start exposing fatal weaknesses, overheating, instability, or microscopic cracks that cannot be seen until it is already too late. But reports from inside the program did not point to those problems. The engine reportedly handled full thrust without major issues. It responded cleanly to throttle changes. A former deputy director at COMAC, someone who had watched the C919 struggle through delay after delay, said the CJ1000A was exceeding his most optimistic expectations. In an industry where caution is almost instinctive, that is a remarkable thing to say. That does not mean the CJ1000A is ready, but what matters more is where it now sits in the development cycle. To get a realistic picture, put it next to the engines that currently dominate the narrow-body aircraft market. The LEAP 1C, the engine currently powering the C919, uses ceramic matrix composite materials, advanced composite fan blades, and cooling systems that allow it to operate at much higher temperatures, cutting fuel consumption significantly. In the efficiency race, the LEAP is still ahead. It has more flight hours, more data, and more years of refinement that China simply cannot compress overnight. But when it comes to thrust, the most important factor for replacing the current engine, the CJ1000A, has already reached the range needed for the C919. Its overall architecture is similar in size and class. It cannot beat the LEAP in efficiency yet, but it is capable of doing the job. Compared with Pratt & Whitney's PW1100G, the geared turbofan known for its strong efficiency but also infamous for early reliability issues, the CJ1000A has one unexpected advantage: simplicity. There is no complex gearbox. There is no risk of bearing wear that could force hundreds of aircraft to sit on the ground. Its early learning curve carries less risk. Of course, it also does not deliver the same efficiency level as the PW1100G, but that is not the goal. Many analysts place the CJ1000 closest to the later generation of the CFM56, not in terms of material standards, but in terms of technical maturity and potential reliability. The CFM56 is one of the most proven engines in aviation history. Comparing the CJ1000A to it is not casual praise. It is a sign that the Chinese engine may have moved beyond the danger zone that most engine projects never escape. And that is exactly where the tone among Western analysts is beginning to change. For years, the common assumption was that China would run into hidden problems that nobody could see yet. The kind of problems that only show up after thousands of accumulated flight hours and push a program back by several more years. But the latest test data suggests the opposite. The CJ1000A does not appear to be stuck in the early danger zone. It appears to be moving beyond it. The next question is no longer whether the engine can run. The question is, what does that change? If the CJ1000A receives commercial certification, something that still requires thousands of additional flight hours, teardown inspections after repeated operating cycles, and long-term durability testing, then the C919 becomes something completely different. It is no longer a made-in-China aircraft with a foreign heart. It becomes a complete product with an independent supply chain, protection from export pauses, and the ability to scale production at the pace COMAC wants. COMAC's long-term target of producing 100 to 200 aircraft per year no longer looks unrealistic, at least in the domestic market and in regions willing to accept Chinese certification. But the bigger impact does not stop there. A working CJ1000A means China can build its own independent maintenance and parts ecosystem, the same kind of ecosystem Boeing and Airbus used to establish their dominance for decades. Countries across Southeast Asia, the Middle East, Africa, and Central Asia could buy C919 aircraft with CJ1000A engines without depending on any Western supplier. No trade leverage. No geopolitical pressure from Washington or Brussels. For Boeing and Airbus, this is not an immediate threat. The C919 still needs years before it can receive EASA or FAA certification and enter the global market on a major scale. But the real concern is not today. It is the direction this is heading. If the first version is already this stable, then the second version will be better. The third will be more powerful. And by the fourth or fifth generation, the performance gap with the LEAP or the PW1100G, a gap that is still obvious today, could shrink to the point where it no longer matters commercially. This mechanism is not new. It is exactly what happened with container ships, solar panels, lithium batteries, smartphones, and electric vehicles. China does not need to win in the first round. It only needs to enter the ring and stay there long enough to learn, improve, and scale. Maybe the most important part of this entire story is not what the CJ1000A can do today, but what it is getting ready to unlock. The technical success of the CJ1000A does not erase Western leverage overnight. Bringing an engine from flight testing into commercial service still takes years. Chinese civil certification is one thing. Convincing airlines to trust that engine with hundreds of passengers on every flight is something else entirely. And the question of long-term durability data, the kind of problems that only appear after hundreds of thousands of operating hours, is still unknown. But all of that now speaks to timing, not technical possibility, and that is the real shift. For years, the Western aviation industry bet that China would never cross the technical threshold required to build a next-generation turbofan engine. The CJ1000A data is challenging that bet, not through some flashy launch event, not through a claim that it has beaten the LEAP, but through something much harder to argue with: thousands of accumulated flight hours, stable performance, and steady progress. The latest test results do not create a headline saying, "China has surpassed the West." They create something far more difficult to deal with: an engine core that is working, stable thrust, clean response, and flight hours stacking up in the right direction. Nobody can say for sure how long it will take for the CJ1000A to qualify for commercial service. But the more important question now is no longer, can China do it? It is this: when China finishes the current version and begins developing the next generation, which is likely already being built in secret, what will the aviation world look like then?